Hi, this is Harini. Uh, Welcome to our channel, Code with Harini. In this channel, we are going to solve the Delhi Lead Code challenges that is coming up. So today we are going to solve the lead code challenge. Find the original typed string. So as part of this video, we can expect the problem explanation, and what is the given input and what is the output, how we have arrived at this output, and pseudocode, and as well as the working solution for this given question. So I will not be solve the solution as part of this video, but I will given you enough information or ideas to how to approach this solution. I expect you to go and personally solve the lead code challenges and make your video useful for you. Yeah. Okay. Without wasting time, let's get into the solution. Let's get into the question. So first, if you look in what they have given. So a girl called Alice, she is attempting to type some string on her computer, but she's sometimes unknowingly she's typing a key for so long, so which results in a character is typing multiple times. So even though she was focusing not to press a key for so long, but still she is pressing some key at most once. So they have given us the final output for whatever the string that Alice typed. So if you see here, they have given. So now we have to return the number of possible substring that she intended to type. Okay, she might have intended to type. So for example, if you see here A B B C C E, see this is the final output. Somehow she mistakenly pressed at most one key for so long. So at most one means it's either 0 or to the max it could be only once. So that's what they are telling. So she might not even intended to press any key long. So this could be the expected string, but what they are telling, what all the possibilities that we can come up with. For example, here they have given possible substrings A B B C C C C. So this is the original string. Maybe she wanted to type this only, she didn't make any mistakes, she didn't press any key for so long. So here we are assuming, okay, she pressed the C 4 times, but we wanted only thrice. So she could have been she wanted only twice or once. So we don't know. So we are assumption. So either one string she can make a mistake, right? So here C could be thrice or twice or once. 4 already is present in the given string, or she wanted to type B once. So the possible substrings are 5. I hope the enough explanation I have given for this particular example. So then if you see A B C D, here she have typed everything once, so we can't assume anything. So here if you see A equals to 4, she might have a possible substrings they have given output as 4. So she might have intended to type A once or twice or thrice, but she have typed 4. So these are the possible 1 2 3 4. So possibly we can assume it as 4. So now I can explain you how this works. So now the last example that we have seen is A input equals to 4, output equals to 4. How does 4 comes? So she might have wanted to intended to type A only. So the possible substring, so let's assume possible substring, let's have this possible strings is equals to 1, because she might have intended to wanted this only to type, so we can take it as 1. If not, so what she might have intended to type A, so we can add to count plus another one, it could be a that they have given already. So a she might have wanted to type a, or she wanted to type so now from this example we can judge, okay, whatever the given string, that many possible substrings we will have, so possible strings that we will have, but it's not. So when another b comes or c comes, so the whole substring we will be taken into account as a one. Okay, so these are possibilities that we could have for a characters, right? So then let's assume, then let's assume she wanted to type a 4 times but not b 3 times. So what are the possibilities for b? So 3b is already given in the given string, so 1b or 2b only possible. So that's what. For if she intended to print c thrice, sorry, b thrice but not c, so 1 twice, c is already they have given thrice. So whatever she was intended to print, how many for example, how many characters were present in the original string will be considered it as a one only. Okay, if it is 3 4, how many consecutive characters she intended to print, all will come together as a in a single possible string. Other than this variations only we will be taken into account. A one thrice, twice, once, B once, twice, C once, twice, because thrice is already here, so that we will not count into another variation again. Okay, because another variation if you take also, what will become, it will be the original string, right? For example, let's assume once two, if you take an a again, it will be the original string. So we wanted a unique variation, right? So that's why we will not taken into 4 again. I hope the explanation makes sense. Now let's look into the pseudocode, how we are going to array. So another thing before going into the pseudocode, I wanted to make you understand one more thing. So for any given possible string, we will be taken the possible string as a 1 initially for whatever they have given. That is also a possible, right? Because at most means 0 mistake she would have done, so this is also possible. So or for 0th chance, whatever the given string is possible. For one possibility we are generating what all could be, right? So in that you just assume whatever the given consecutive characters in a string, if you are taken a into account, which is of length 4, 3 possible. So basically 4 minus 1 3. So if you taken b into account, 2 possible, correct? So which is basically 3 minus 1. If you take c also 3, we are generating 2 possible strings. So basically n minus 1, n here is length of consecutive characters. So for that we were getting n minus 1 possible strings. So that's what. Now we will be what we can do, we can take now let's go to the pseudocode. Okay, maybe I can write here def count possible strings. Okay, we are getting n cs as a string, so we'll have a count equals to 0 and possible strings, generally whatever they have given it's a possible, so we'll have a count as a 1, so which I have explained here now. So possible strings equals to 1. Now we'll have another extra character, sorry, possible strings only now, sorry. Okay, now we will be traversing through each character in S, and we will be adding that so, okay, we'll have a previous variable as well, which is empty initially. So we will be checking previous equals to the current string. Then what we are be doing, count plus or equals to 1. Else we will be appending the current character as a previous, and possible strings will be plus or equals to whatever the count. Here count equals to 0. Why we are given the count equals to 0? Because as I told, for n characters we will be n minus 1. So if you take 0, 1, 2, 3, we will be always, anyway n minus 1 will come, right? For the first character, if you taken the count as a 0, for at the x at the length of 4, we will have the count as a 3, which is already n minus 1. So that's how it works. Maybe I can just run through an example of A, B, 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 C, C. Okay, now previous, let's have a variable here, previous count possible substrings. We'll have 3. Previous equals to A, sorry, initially previous equals to empty, previous equals to empty, and x equals to A. So previous, now previous is getting appended to 0, count as 0, possible substring is already 1. So it will be like this. So when B comes also, again previous equals to A, x equals to B, right? So that is also not possible. So now previous equals to A, x equals to B, right? So now previous will get updated to B. I'm just reducing the thickness. Okay, previous equals to B. Now count is again set to 0, possible substring is still 1. So when B equals to B, count is getting updated to 2. Next, sorry, count, now only the count will be updated. When here it comes, count will get updated to 2. Next, when B comes here, count is getting updated to 2. So when x goes here, so previous equals to still B, x equals to C. So again it will go and it will update the previous as equals to C. Possible substring is 1 plus 2. Okay, count again updated to 0. Okay, now when C comes, we have 2 C's, right? Now again when it navigates to the last C, C equals to C, and count will be updated to 1. It will, now it won't go to the else condition. So what we have to do in the end, we have to return whatever the possible substrings we got plus count, because at the end also if we have the same consecutive characters, it won't go to the else condition, we will miss the last count equals to 1. So it will return 4. So now we can just go, I can manually explain how that 4 comes. So A is nowhere, so 1B, 2B's are possible, right? So the same way only 1 C is possible. Already 2 C's are given in the original string. So these 4 are the answers that we have given. So here if you just look into this example, we can still reduce variables. We have two if conditions, else conditions. Like previous is nothing but I minus 1. Whatever this I, So let's take this two. Let's take this two. If assume this is the I, this is I minus 1. So basically if I and I minus 1 are equal, you just append the count. So instead of appending the previous here, then making the count row, when again it comes in the next loop, previous equals to current, previous equals to current character, appending the count, we can straight away avoid this by, for I in range, we'll start with n length of s. Okay, so initially have the possible strings as 1, as we discussed why we are giving the possible strings as a 1. The given string itself a possible, so what we can do, we can just check if s of I minus 1 equals to s of I possible string plus or equals to 1. Basically we are adding the count only, right? The count is nothing but I of I minus 1. So straight away we can add, so that we can avoid another else conditions and too many variables. That's it. By this also we can solve the we can solve the question. So here the time complexity is order of n. N is n, basically n is nothing but length of, yes, we'll be just traversing through the length. Yeah, I hope you guys would have understood. Maybe I can just make you see the submitted solution that I have. The same way here I have just given extra characters, that is nothing but the possible strings. Maybe we can just update that. Possible strings count. I'm just updating that so that it will be, you guys will understand it better. Now I just ran through the solution. Yeah. Now if you see, we are checking previous equals to word of I, and we are adding the count as we discussed, why we are giving initially the word of I. If it's not equal, then we are updating the possible string count when the two characters is not consecutive. So previous equals to word of I is nothing but word of I minus 1. So there is no need of having a else condition. Maybe if someone arrives at the solution like me, maybe I'm just telling why we can have, how we can avoid the else conditions as well. So I hope this is clear to you. I also expect you guys also should solve this question and make the video useful for you. Yeah, I will also, it's a Python solution, I will also attach in the description below with a GitHub link that will have Java, C++ and all other languages. So maybe if someone wants to, still couldn't come up with the solution or have any doubts regards, you can just go and check out the solution. Yeah, feel free to leave the comments. Yeah, happy to hear your feedback. Thanks for watching.